Have you ever stopped and thought about how our brains, these physical things can create something as I don't know, intangible as our thoughts and feelings?
It really is a pretty wild thing to think about.
It's a question that's baffled people, really smart people, for centuries. How do we go from, neurons firing to the experience of actually being conscious?
Right. It's a real head scratcher. And this draft paper that you shared with me by Carrie Draper and ChatGPT, they're actually trying to answer that very question
Oh, wow.
using a framework called Embodied Predictive Global Workspace, or EPGW for short.
EPGW. Okay, I'm already kind of hooked. So what's the main idea?
Well, EPGW basically says that our brains are constantly making predictions about the world around us, almost like they're running simulations based on everything we've learned,
Okay.
trying to anticipate what's going to happen next.
So my brain is like a tiny little fortune teller running all the time.
Yeah, that's a great way to put it.
But okay, what happens when those predictions are wrong?
Well, that's when things get really interesting.
Okay.
When a prediction fails, our brain gets a signal, a prediction error. It's basically like a flag that says, hey, something's not quite right here. Pay attention.
So that's like when I think, oh, I didn't see that coming. That's my brain getting one of those error messages.
Precisely. And those errors aren't actually a bad thing. They're super important for learning. They force us to update our understanding of the world.
Okay.
And refine that internal model of, how things work.
So learning is our brain basically just becoming a better and better fortune teller, trying to get fewer and fewer of those error messages.
Yeah, I like that.
But here's something I'm wondering.
Yeah.
If our brains are getting all these errors all the time, how do some of them become the thoughts that we're aware of?
That's a great question.
Right. Why aren't we overwhelmed by every little, I don't know, mismatch between what we expect and what actually happens?
Right. Well, EPGW says that the really important errors, the ones that need our attention, get sent to a central hub in the brain called the global workspace.
So it's not just random errors going everywhere. There's some kind of system.
Exactly. It's like a filter.
Okay.
And get this, when an error makes it to this global workspace, that might be what creates conscious awareness.
Oh, wow.
It triggers decision-making, changes in our behavior, all those things that make us think, hey, I'm really thinking about this now.
So these errors aren't just about learning. They could be the reason we experience consciousness at all. That's a pretty big idea.
It is a pretty big idea. And there's another layer to this that I think is really fascinating.
Yeah.
EPGW emphasizes that our brains aren't just isolated up in our heads. Our bodies and how we interact with the world are also super important.
So we're not just brains in jars, but how does our physical self get involved in all this brain prediction stuff?
It's called embodied cognition. And basically it means that our predictions are shaped by what our bodies can and can't do.
Okay.
How we move, what we sense, all that feeds back into how our brain models the world.
Okay, give me an example. I'm a little lost.
Okay, sure.
I need to picture this.
Okay, let's say you're learning to play, I don't know, a piano.
Okay.
As you practice, your brain is predicting how your fingers should move, what the sound should be.
Okay.
When you hit a wrong note, you get that error signal.
Right.
But that error isn't just in your brain. You feel it in your fingers, you hear the wrong sound. Your whole body is part of that feedback loop.
So with practice, we get fewer errors, our predictions get better, and we get better at playing the piano.
Exactly. It's this constant back and forth between our brain, our body, and the world around us.
It makes me think about all kinds of learning, not just playing an instrument. Is there a way to use this, this prediction error idea to learn things better in general?
That is a great question. And that leads us to another really important idea in EPGW, the free energy principle.
Free energy principle. Okay, that sounds kind of complicated.
It's not as bad as it sounds, I promise. The main idea is that living things, even our brains, are always trying to minimize free energy.
Okay.
Which is basically a way of measuring surprise or uncertainty. Think about it. Too many surprises can be totally overwhelming.
Yeah.
So our brains try to find patterns to make sense of things,
Makes sense.
to make the world feel more predictable.
So our brains are like little detectives, always looking for clues to solve the mystery of what's going to happen next.
I like it. You're good at this.
But, okay, so if we're always trying to avoid surprises, to minimize that free energy, how do we ever deal with unexpected events, wouldn't those just create a ton of free energy?
That is a really great point, and that's actually where the free energy principle gets really interesting. It suggests that our brains are constantly fine-tuning our internal model of the world. And yes, unexpected events do create that surge of free energy, a kind of jolt to the system.
Right.
But here's the key: that jolt pushes us to adapt, to learn, to update our model.
So those unexpected moments, those surprises, are actually what helps us learn and grow.
Absolutely. It's this constant dance
Hmm.
between minimizing surprise and then using those surprises to learn and grow.
I'm starting to see how this all fits together. It's
Yeah.
like our brains are these prediction machines, our bodies are part of that whole process, and this free energy principle keeps pushing us to learn and change. It's kind of blowing my mind. But this is all very theoretical, right? Is there any way to actually test these ideas out?
There is, and this is where it gets really exciting.
Okay, lay it on me.
We can actually use something called BrainLM.
BrainLM. Okay, you're going to have to break that one down for me.
It's a really cool computational model.
Hmm.
Basically, it's a way to simulate how the brain works using computers.
Oh,
It can help us test and refine those predictions from EPGW. It's almost like we're getting a little peek inside this incredible prediction machine.
okay, hold on. I think I'm going to need a little more info on this BrainLM thing and how it all works.
Yeah, we could definitely dive into that more.
But before we do, I think we should also talk about how EPGW compares to some of the other big theories out there about consciousness.
That's a great idea.
Yeah.
It's important to see how EPGW fits into the bigger picture of all this consciousness research.
Sounds like a plan. We'll explore all that in part 2 of our deep dive into consciousness.
Looking forward to it.
All right, so we've kind of laid the groundwork for this Embodied Predictive Global Workspace thing, EPGW.
Right.
But now I'm curious how it stacks up against some of the other big theories out there about consciousness.
Mm-hmm.
You know, we touched on the global workspace theory a bit earlier.
Right.
Can you remind me how that one works and where EPGW fits in?
Sure. The global workspace theory basically says that consciousness happens when information gets broadcast to a global workspace in the brain.
Yeah.
It's like making that information available for all sorts of different cognitive processes.
Okay.
You can think of it like a stage where different parts of the brain, different modules or processors can access and use the information.
So it's like a central hub for everything that's going on in our brains.
Exactly.
But how does EPGW, add to that?
Well, EPGW takes that idea a step further.
Okay.
It suggests that the information that gets broadcast to the global workspace isn't just random. It's those prediction errors, the ones that really stand out,
Yeah, okay.
the ones that don't match up with what our brain expects. Those are the ones that make it to the global stage.
Ah, okay.
So EPGW gives us a reason for why certain information gets broadcasted.
Right. It's the stuff that could really shake up our understanding of reality, right?
Exactly. And remember that whole free energy thing we talked about?
Yeah.
Minimizing surprise and all that.
Right.
Well, resolving those prediction errors in the global workspace, that's how we do it. It helps us make sense of things and create a more, stable model of the world in our brains.
Okay, that makes sense. Now, what about integrated information theory, or IIT?
Right.
How does EPGW compare to that one?
IIT is interesting. It proposes that consciousness is all about how much integrated information a system has. The more information is both differentiated and integrated, the more conscious the system is.
So a brain with lots of interconnected parts all working together would be considered highly conscious.
Yes. And that's where EPGW and IIT actually complement each other quite nicely.
Oh.
Because EPGW suggests that resolving those prediction errors, that's an integrative process.
Explain that.
You're taking your prior expectations, combining it with the sensory data coming in, and updating your model.
So those surprises, those errors, they're actually helping to connect different pieces of information in our brains.
That's the idea. And that integration, that connecting of the dots, could be a key part of what makes us conscious, according to EPGW.
Okay.
There's actually another theory we should probably talk about.
Okay.
It's called temporal binding theory, or TBT for short.
All right. Tell me about that one. What's the main idea behind temporal binding theory?
TBT focuses on how important neural synchronization is for consciousness.
Neural synchronization.
Basically, different parts of the brain processing different parts of an experience.
Okay.
They need to fire together in sync for that experience to become conscious.
So it's like, I don't know, like a choir where all the voices need to be in harmony to create one unified sound.
So that is a perfect analogy. You're getting good at this. And guess what?
Yeah.
EPGW suggests that those prediction errors, the ones we've been talking about all this time,
Yeah.
those can actually trigger these synchronization events in the brain.
Hold on. So a surprise, something unexpected, can cause different parts of my brain to start firing together.
Exactly. It's like a sudden aha moment where everything clicks into place.
That is pretty wild.
It really is remarkable.
It's like EPGW ties in with and even adds to all these other theories in some way.
It's true. It's kind of weaving them all together.
So we've got EPGW building on that global workspace theory, complementing integrated information theory, and connecting with temporal binding theory. It's like this big web of ideas.
It is. And, we talked about dual aspect monism earlier.
Right. How does that fit into all of this?
Dual aspect monism is basically the idea that mental and physical stuff, they're two sides of the same coin. They're connected. You can't separate them.
Okay.
And this is actually where EPGW is a bit different from some of those other theories.
In what way?
It doesn't see this hard line between the mind and the body.
Okay.
It suggests that consciousness comes from this dynamic interplay between those prediction processes we keep talking about and our physical bodies.
So we're not just brains thinking in isolation.
Not at all.
We're brains and bodies all wrapped up in one package, constantly interacting with the world around us.
That's a great way to put it. EPGW really pushes this idea that consciousness is about the whole system working together.
So it's not mind versus body, it's mind and body working together.
Exactly.
Fair.
And you had that great question earlier about whether we can use these EPGW ideas to become better learners.
Right.
I haven't forgotten about that.
Okay, good.
But before we jump into that, there's one more really fascinating piece of this whole EPGW puzzle that we need to explore.
Oh, now you've got me really curious. What else is there?
Well, EPGW isn't just about how our brains work. It actually has some really cool practical applications.
Wait, really?
Especially in things like artificial intelligence,
Oh, wow.
neurorehabilitation, and even education.
You're telling me this isn't just some mind-bending theory? There's actually stuff we can do with it.
Absolutely. We're talking about the potential to, really change how we understand and interact with the world around us.
Okay, I definitely need to hear more about these applications.
I think we should save those applications for part 3 of our deep dive.
All right, you're right. My brain probably needs a little break to process all of this before we jump into applications.
Sounds good to me.
We'll pick up right where we left off in part 3.
Can't wait.
All right, so we've really gone deep into this whole embodied predictive global workspace, EPGW thing.
Yeah, it's a fascinating framework.
It's like our brains are always predicting, our bodies are part of it, and we're driven to avoid surprises.
Right.
But now I really want to hear about those real world applications you mentioned.
Okay, yeah.
How does EPGW go from a theory to something that could make a difference?
Well, one of the most exciting areas is definitely artificial intelligence, AI. Imagine AI systems that can learn and adapt kind of like our brains do.
Oh, okay.
Using prediction and error correction.
So instead of just following rules that, someone programmed into them,
Right.
these AI systems could actually learn from their experiences, like out in the real world.
Right. Exactly. They'd be constantly making predictions, testing them, and then updating their models based on what they learn.
So they'd be more flexible, more adaptable.
Much more. Yeah.
Than the kind of AI we have now.
Right. It's a whole different way of thinking about AI.
They'd be thinking more like us, right? Trying to figure out what's going to happen next and how to respond.
Exactly. They'd be able to deal with unexpected stuff much better, which is really important if we want AI to be a bigger part of our lives.
That makes sense.
Think about self-driving cars, for example.
Okay, yeah.
Instead of just reacting to obstacles, they could anticipate problems based on, what they've learned. It would make them way safer and more efficient.
It's like they'd be, more aware of their surroundings.
Exactly. And it goes way beyond self-driving cars.
Okay, like what?
Think about healthcare, finance, you name it.
This is pretty mind-blowing. Okay, so EPGW could change AI.
For sure.
You also mentioned neurorehabilitation.
Right.
What's the connection there?
Well, one of the things that EPGW really highlights is the brain's plasticity.
Okay.
Its ability to rewire itself.
Right.
Which is super important when we're talking about recovery from things like brain injuries or strokes.
Okay, yeah.
If we can understand the specific prediction errors a patient is having, we could tailor therapies to really target those areas.
Okay.
And help the brain rewire those pathways more effectively.
So we'd be working with the brain's natural ability to learn and adapt.
Exactly.
That'll help it heal.
It's like giving the brain a personalized roadmap for recovery.
That's
It
amazing.
really is cutting-edge stuff.
You mentioned education too, right?
Yes. This is where that embodied cognition idea comes in.
Okay, remind me, what was that again?
But remember, it's the idea that our bodies are part of the learning process.
Oh, right.
EPGW reminds us that learning isn't just about sitting there and passively taking in information. It's about actually interacting with the world, making predictions, even making mistakes.
So instead of just listening to lectures all day,
Right.
we should be out there like experimenting and exploring, getting our hands dirty.
Exactly. Think about how kids learn. They're always playing, trying things out, getting things wrong, and trying again.
It's true, they're little scientists.
Exactly. And that's how they build their understanding of the world.
So EPGW could help us design schools that are more hands-on, more interactive.
I think so, yeah. It could be really transformative.
I'm seeing how all these pieces fit together.
Yeah.
AI, neurorehabilitation, education, they're all connected to this idea of the brain as a prediction machine.
That's the beauty of EPGW, I think.
It's not just a theory about the brain, it's a theory about how we learn and interact with the world.
And maybe even how we could create more intelligent systems in the future.
It makes you think about the ethics of it all, too, especially with AI.
Absolutely, yeah.
If we start creating AI that's really similar to human intelligence, we need to be careful about how we use it.
Yeah, that's a really important point. As AI gets more sophisticated, we need to make sure it's used responsibly and ethically.
So EPGW isn't just a cool scientific theory. It's something that can have a real impact on society.
I think so, yeah. It raises a lot of big questions.
About consciousness, the future of AI, and, what it means to be human.
Exactly. It's a whole new way of looking at ourselves and our place in the world.
Well, I know I've learned a lot from this deep dive.
Me too.
It's definitely given me a new perspective on, my own mind.
It really makes you appreciate just how incredible our brains are.
To everyone listening, I hope this has sparked some curiosity about consciousness.
Yeah, it's a mystery that's worth exploring.
And hey, the next time you're surprised by something, remember your brain is doing an amazing job predicting the world around you.
That's right. And maybe someday, thanks to frameworks like EPGW, we'll have AI systems that can learn and adapt right alongside us.
Well, that's it for this deep dive. Thanks for listening.
Thanks for having me.